Hello dear students, today I will discuss about transportation problem. That is the last topic for LPP, linear programming problem. So in the previous class we have seen that the diet problem and profit loss problem, manufacturing problem. So here transportation problem. Transportation problem means materials for supplying what will be the best schedule for supply material from one place to another place with cheapest cost. Okay, here what for cost of transportation should be minimum for transporting materials from one place to another place. This type of problem also can be solved by formulating, mathematically formulating, that is formulating LPP for the given problem, and by graphical method we can find the minimum cost for the transporting materials from one place to another place. Okay, so there are questions, some questions are given in also in examples and also in the exercise, miscellaneous exercise. Okay, on chapter 12. So here the first question, not first question, means question 6 related to, in miscellaneous exercise, related to transportation problem. So question 6, miscellaneous exercise question 6. Okay, so just read the questions very carefully, and then first of all formulating is necessary, and then we can solve it for minimum cost of transportation. Okay, so here the question 6, just two godowns A and B have grain capacity of 100 quintals and 50 quintals respectively. Two godowns. Okay, suppose for diagrammatically representation, give very simple technique to write constraints here. We know the constraints for LPP. So here just give in the given questions there is given also table is given also. Okay, so just from table, in the table the transportation cost per quintal in rupees is given. Okay, so just DEF, there are 100 quintals and 50 quintals capacity have to go down. So for diagrammatical representation, from diagram we can write constraints just like this. Suppose this is go down, this is go down A. Okay, go down A, capacity 100 quintals, 100 quintals. And go down B, just draw here. Go down B 50 quintals. Okay, 50 quintals. Go down B 50 quintals means what? Capacity. Go down A, go down B. There are two go downs and they are supplying grain to the shop. Here, these are the capacity. Just go downs, two go downs, maybe three go downs, but here two go downs. Okay. Now, this two go downs supply to three shops D, E, and F. Name, whose requirements are 60, 50, and 40 quintals respectively. So three shops are, suppose this. First shop is this, second shop is this, third shop is this. The three shops. Okay. SHOP shop, D shop, E shop, E and shop F. Three shops are there. Both go down supply grains to these shops. Okay. Its requirement 60, 50, 40. 60 quintal, 60 quintals. 50 quintals. 50. Quintals, okay. Quintals, and this is 40 quintals. This is requirement. This shop D, shop E, shop F required 60 quintal, shop D, E requires 50 quintals, and shop F requires 40 quintals. Okay. Now just A supply to D, to E, to F, and similarly B supply to F, B supply to also E, and B also supply to D. Okay, so the cost of transportation per quintal from the godowns to the shop are given in the following table. This table gives cost from D, E, F, from godown to D, godown to E, godown to F, from A to from B to. So how many rupees per quintal rupees? Per quintal rupees. So here just from the table it is clear that, and question is given as how should the supplies be how should the supplies be transported in the order that the transportation cost is minimum? How should we schedule, and what is the minimum cost? So here just LPP we have to form. Just in the table it is clear that transportation cost is given from A to D is rupees 6, here rupees 3, this given in table, rupees 2.5, 2.50. This is given in table from A to D, E, F. Similarly, 4 to 3, rupees 4, rupees 2, rupees 3, 4, 2, 3 in the table given. Okay. So these are the rupees from go down B to go down D, E, F. Cost per quintal. It is given in table 4 to 3. So 4 to 3, 6, 3, 2.5, 6, 3, 2.5. Okay. And here, suppose how much quantity supply A to B, D, suppose X quintal, and A supply to E Y quintal. Clear? D and E. Select. Just we have to draw the diagram here. Okay. Suppose here, let's go down A, X quintal grain supply to D, and go down A, Y quintal supply to E. Then it have 100 quintals. So X quintal and Y quintal for this and this. So remaining are for F. 100 minus X minus Y. Because total 100. So X quintal here, Y quintal here supplies. So remaining 100 minus X minus Y quintal supply to F. So these are the supply, this quintal, this quintal, this quintal to this DEF through from AB, from go down A. Similarly, go down B, from go down B, suppose this. Now, here what will be? Because X quintal, its requirement 60 quintal. X quintal sub D already got. Now, how many remains? Because 60 minus X, 60 minus X, because X quintal comes, so 60 minus X quintal is required, so that is supplied from go down B. Similarly, here its requirement 50, so 50 minus Y quintal, 50 minus Y, so here 50 minus Y, it requires 50 minus Y, 50 minus Y, this quintal, 50 minus Y quintal, it's required because Y quintal already got. So 50 minus Y remaining requirement supplied from B. And go down B, supply to this 60 minus X, 50 minus Y. So remaining 50 minus this should be go to F. So what will be the value from here? Just 50 total. So 50 minus these two are subtracted. So minus 60 minus X minus 50 minus Y. So here we see that what? Minus minus plus minus minus plus. So X plus Y minus 50 minus 50 cancel out, minus 60. X minus X plus Y minus 60. So X plus Y minus 60. So remaining are supplied to x plus y minus 60. So this quintal supplied to F. This is in quintal. This is rupees per quintal. This quintal supply grains from B to D and rupees per quintal cost. So transportation cost may be written as this into this plus this into this plus this into this. Also this into this plus this into this plus this into this. Okay. So per go down, how can you write the cost? This into this, this into this, this into this. For this, just we have require x and y. Then we can write everything. Okay. So now our target is what? Finding a and x and y, such that the cost should be minimum. So just we can say from here what? X should be greater than equal 0, y should be greater than equal 0. Similarly, this is greater than equal 0, this is greater than equal 0, this is greater than equal 0, this is greater than nothing greater than equal 0 means maybe 0 or not negative. Then you can find the here just write x greater than equal 0, y greater than equal 0 should be similarly 100 minus x minus y is greater than equal 0. Okay. So what is given here? X plus y go to right hand side. So x plus y is less than equal 100. So we get x is greater than equal 0, y is greater than equal 0, and x plus y is less than equal 100. So these are the constants also. And also what? Here 60 minus x is greater than equal 0, 50 minus y is greater than equal 0, and x plus y minus 60 is greater than equal 0. So this gives what? X is less than equal 60, y is less than equal 50, y is less than equal 50, y right go to right hand side, and x plus y is greater than equal 60. So this and this are the constraints. And cost, total cost. Total cost may be written as what? Just this into this plus this into this plus this into this, this into this plus this into this plus this into this, just write. Okay. So x into 6, 6x plus 3y, 3 into y. Here 2.5 into 100 minus x minus y, 2.5 into 100 minus x minus y, plus similarly these also 60 minus x into 4, 4 into 60 minus x plus 2 into 50 minus y, 2 into 50 minus y plus 3 into x plus y minus 60. Total cost. Total cost. So this is equals to also we can write, just solve it. What? 6x minus 2.5x minus 4x minus 6.5. So 6 and 3, 9x, 9 minus 4, 6.5, 2.5. Okay, so 2.5x, 2.5x. Just this plus 6x plus 3x minus 4x minus 2.5x. 2.5x finally. And also for y. So here 3y, 6y minus 2 to 4.5y, 4.5, 6 minus 4.5, 1.5y. So 1.5y. Clear? And also constant term you can collect what? 10 into this 25, 100, 25 minus 25 here, 4 into 60, 240 and 100 and 5, 6, 365. Okay. And minus 360 here, minus 180, minus 180. So this is equals to what? 2.5. So here this is 100. Sorry, this is not 10. This is 100. This is 100. 100 minus. So 250, 250, 250. So 6, 9, 0, 9, 590. So 0, 1, 410. So plus 410. So this is cost function. Okay, z equals to. We have to write z equals to this. Clear? So cost function and these are the constraints. So formulation can be done by writing what? The cost should be minimum. So the formulation can be the problems given in the questions can be formulated as thus. The problem can be formulated as minimize z equals to minimize. This should be the constraints. Okay, so here we can write like this. X plus is equal to 100. So minimize z equals to value 2.5 x plus 1.5 y plus 410 subject to constraint. Subject to constraints. Constraints are both combined. Just how? First, x plus y is less than equal 100 and x greater than equal 0, y greater than equal 0, first value, and then x less than equal 60, y less than equal 60, y less than equal 60, and x plus y is greater than equal 60. So these are the constraints. Okay, x plus y is less than equal 100, x is less than equal 60, y is less than equals 0, and x greater than equal 0, y greater than equal 0, and also x plus y is greater than equal 60. So these are our constraints. Just to solve this problem graphically, we have to draw the graph of this. Okay, this is helpful, this diagram, for making cost function, and that is objective function, and writing constraints. So transportation problem can be formulated by using this diagram, basically representation with the help of the given table in the questions. So see the table and draw this diagram, just represent diagrammatically, and then you can write very easily constraints from here, because all things are this should be greater than equal 0, this greater than equal, this greater than equal 0, and cost this into this, this into this, this into this, and 6 costs are summarized. That is total cost. This constraints to minimize cost. Cost is minimized subject to the constraint. This is formulation. Okay, so this is formulation. Now we have to find minimum cost. What will be the schedule for minimizing the cost? That is, what is the minimum cost? So just solve this LPP using graphical method. So for that we have to draw graph. Okay. We know the graphical method. Just one by one draw. Very simple. Just first of all draw the graphs, and then if region is unbounded, bounded, then just find the corner points, and at all the corner points find the value of total cost, the reject, and minimum value is minimum and maximum is good here. Just minimum value is the minimum cost, and cost for schedule at the point for xy. So just by using xy we can write the cost for each. For each go down for the shaft AB, here D, E, F. Clear? So here just draw the graph. For drawing graph, suppose just this is y axis, and this is x axis. This is origin. Clear? So for drawing graph, we can see that here for drawing this, just x plus y is equals to 100, that is x by 100 plus y by 100 equals to 1, means 100 0 and 0 100. So 100 is required here. For also it x by 60 plus y by 60, and here point is what? 60 0, and here 0 60, or here point what? 100 0 and 0 100. These are the point. Just draw the point. Clear? So take scale on the graph. Okay. So suppose this is 10, then 100 we require 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11. So this is 100. Okay, take this is 100. Just this 100. Here 10, 20, 30, 40, 50, 60, 70, 80, 90. This is 110. Similarly, here just take graph. Just take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 100. Okay? 90, 80, 70, 60, 50, 40, 30, 20, 10. Just take small part because the space is required, that's why. Just you can draw this line here also. Okay, so draw the graph. Now, this is 100, 10. Now 10, 0, 100, 0 is this. 0, 100 is this. And 60, 0, 60 is this. And 60, 0 is this. Just we have to draw. And here, x is greater than equal to 0 means right side. Y is greater than equal to 0 means upper side. X is less than equal to 60 means x equal to 60 line we take. Just this line. So here we have to draw line first of all. What? This. So draw the line. Not from here, from 100, sorry. From here. This is not the point. 100. This is the point. Okay, just draw the graph of a straight line. This is line. X plus y is equals to 100. X plus y equals to 100. Clear? And 60, this two. So here, just draw the line. Okay. So this is 60. This is line. X plus y equals to 60. X plus y equals to 60. Draw the straight line. Now, x equal to 0, y equal to 0. This is x equal to 0, this is y equal to 0. Sorry, this is y equal to 0, this is x equal to 0. X equal to 60. This. Parallel line to this. So, this is x equals to 60. And x equal to less than also what? $50. X equal to less than also 50. Not 50, y is less equals to 50. Y is less than equal to 50. Sorry, y is less than equal to 50. X is less than equal to 60. Y is less than equal to 50. So y equals to 50 also you have to draw. So y equals to 50 is this line. Okay, from here. This is y equals to 50. Y equals to 50. 4 lines are drawn. Now for first, x plus y is less than or equal 100. So 0 plus 0, origin line, or 0 less than or equal 100, right? Also 0 here not. For this, that is for 100. So solution side is this side. In the side where origin line, this side. And for this 0 plus 0, 0 greater than or equal 60, wrong. So for this half plane does not contain origin, is the solution. It is this side. This side means what? This side, and it's this side. That is this in this portion. Solution should lie. Region should lie. Now also x is greater than or equal 0, y is greater than or equal 0. Means y is greater than or equal 0 means upper side. And x is greater than or equal 0 means this side. This side and this side. That is in this side, in this region. And in this region, in first quadrant, region line in the side of origin from this line, and in the opposite side of the origin for this line, that is in this portion. Also, x is less than or equal 60. This 0 does not satisfy. So x is less than or equal 60 means 0 satisfy. Also 0 satisfy. So origin side. So this side and this side. So this side and this side. Origin side. So in this side, in this side, in this side, that is our region will be what? This portion. Okay, just you have to shadow this region. So corner points are this. These are the corner points. This shaded region is our visible region. This is visible region. Visible region. Okay. Now corner points are ABCD. Suppose this is A, this is B, this is C, and this is D. Just find the coordinate of this point. Okay. So the corner points are, now this is a graphical representation of this problem. Okay. Now we have to find the values of z at all the corner points for the corner point method for solving this LPP. Okay. So just find the value of z at corner points. So the values of z at corner points are A, B, C and D are, just make table. Okay. Here corner points are and value. Corner points and z equals to 2.5x plus 1.5y plus 410. So this is the value of Z equal to this, just calculate the value. A. What is the point? B. Point C. Point D. Point. A is what? Just read. 60, 0. 60, 0. B is the point. Here the value of x is 60. 60. And value of y. Here value of y. This is x equal to 60. Intersection with this. X equal to 60 and x plus y equal to 100. Intersection of this line and this line. Just x equal to 60 here and y equals to 40. So 40. So this is 40. C also. C. Y equals to what? 50. And intersection with this line. That is 50. Y equals to 50. C equals to 50. Sorry, x equals to also 50. Because this line and this line intersected at this. So this is what? 60, 0. B. 60, 40. 60, 40. 60, 40 and this is 50, 50. C. 50, 50. 50 and 50. And D is what? Just intersection of x, y equals to 50 and this line. Y equals to 50, x equal to 10. So 10, 50. So 10, 50. This 10, 50. 10, 50. This 10, 50. Now, x equal to this, y equal to this. Just put here and find the value of z. All the value. Okay. 566, 20. Just 0 here. And this 60, 60. What? 6, 560. We can calculate 60 into 2.5. 2.5 into 60. Okay. So what? 150 plus 4, 10, 0, 6, 560, 560. Similarly, just calculate at 60, 40. X equal to 60, y equal to 40. Just put x equal to 60, y equal to 40. So you can get value here 620. 620. 50, 50. Just at 50, 50. You can also find the value 610. 610. And final value is 510. 510. 1050. Just find the value. After putting the value here, x and y, just add all these points, you can get the value of z. Here 510. This gives, this is minimum value. Minimum. Because region is bounded region. So z equals to 510 is the minimum value. That is, minimum value of z is 510. And at the point, minimum value 510 at the point 10 and 50. 10 and 50 means for x equals to 10 and y equals to 50. So, we can find the minimum cost for was amount of, thus the amount that z equal to, the value of z is minimum at 1050. Thus the amount of grain transportation from godown A, just in the diagram, from godown A to D, E and F means stop, or what is the cost? X into 6, x into 6. So 10 into 6, 60. Then 3 into y, 3 into 150. So 50 is just amount, how many rupees? Okay, so what? First, amount of grain, how many? Because x quintal, y quintal, so 10 quintal. First 10 quintal, because in the diagram there was x, y, and then 100 minus x minus y, so 60 minus 100, 40. So 10, 50, 40. 10, 50, 40 are 10 quintal, 50 quintals, and 40 quintals. This is the amount, how much quantity of grain should supply to DEF from godown AB. Because x, y, and 100 minus x minus y, and respectively, you can write respectively, and also from godown B, from godown B to DEF, DE and F are what? There was what? 60 minus x, that is 60 minus x means 10, 50. 50 quintal, and 50 minus y, 0 quintal, 0 quintal, and there is what? 60 minus x minus y. 60 minus x minus y means 0, and 0 quintal respectively. These are the quantity. You can find these values from, just see the diagram where x, y, 100 minus x minus y, and quantity 60 minus x, 50 minus y, and 60 minus x minus y. So these are the values, and minimum cost for the minimum cost of transportation. As z equals to 510 rupees. So this is the solution of transportation problem of the question 6 of exercise, miscellaneous exercise. Okay. So similar type of questions also given in examples, and also 7 question is also transportation problem, but here cost is not given, here distance in kilometer is given. How much distance from the godown to here what? Company to company A and B, company depot A and B to the petrol pump. So question 7, can also be done by, here distance is given. So we can draw the same type of diagram. Okay. So how many liters are there? Suppose X liter and Y liter, just like this. Just formulation. Just take only formulation for question 7. Okay. Transportation. There is also some questions in example. Just you have to do all the questions from example and exercise. Okay. So just for question 7, we have to draw formulate first of all, and then by drawing you can find a solution. Okay. So question is, an oil company has 2 depots A and B with capacity of 7,000 liter and 4,000 liter respectively. The company is to supply to the 3 petrol pump. Just same type of questions. 3 petrol pump are there. The EF whose requirements are 4,500, 300, 3,000 and 3,500 respectively. The distance kilometer between depots and a petrol pump are given in this table. Okay, in the question. Okay, so here just you can make like this. This is petrol pump A, this is petrol pump B. Just 3 depot are there, D, E, F, just supplying like this. Okay, so capacity, its capacity what? 7,000 liter. Its capacity was 4,000 liter petrol, and both go down or supply to this go down. This question 7. Not go down, this is what? Depot A and depot B. Suppose a distance is given from A to DEF 763. 763. Distance is given. Okay, distance is given. So how many liter? So, just in the question there is given 12.7. Distance is given in the table. You can see distance is given just like this. This 7 kilometers from here to here. Similarly 7, 6 and 3. 6 and 3 kilometers. They are the distance between A to DEF, and another from B to the distance is 3, 4, 2. 3 kilometer, 2 kilometer and 3, 4, sorry, here 4 kilometers. 4 kilometer and 2 kilometers. Distance from this depot to DEF 3, 4, 2 kilometer. This is given in table. Distance is given. Okay. And also in this it is given that Assuming that the transportation cost of 10 liters of oil is rupees 1 per kilometer. Per kilometer. For transporting cost per kilometer 1 rupees for 10 liter. This is given. Transportation cost rupees 1 per kilometer for 10 liters oil. For 10 liters oil per kilometer 1 rupees charge. So the cost per kilometer, cost for 1 liter, therefore cost per kilometer per kimi for 1 liter is equals to 1 per kilometer for 1 liter. 10 liters for this 1 rupees. Cost per kilometer for 1 liter equals to 1 by 10. 1 by 10 rupees. This is cost per kilometer per liter. So suppose X supply X liter, Y liter, then total is 7,000. So 7,000 minus remaining are supplied to F. So what? 7,000 minus X minus Y. Similarly, D requires what? 4,500. So 4,500 minus X. Here 4,500 minus X. And E requires what? 3,000. So 3,000 minus Y. Just like in the previous questions. Here, what will be? F requires how many? F requires 3500 liter. So 3500 liter, 3500 minus this minus 3000 plus y minus 4500 plus x. So x plus y just 3000 means 500 plus means 4,000. So here just minus it is required. So this minus this. So here 35,000 respectively required 35,000 na? So 35,000 100 4500 and 300. So 35 minus 3000 plus y minus 4500 plus x. So x plus y. Here what? 3000 is this 5,000 plus this minus 4,000 is there, no? So 4500, 3,000, 35,000. So 3,000 is 4500 is subtracted from here. So what will be the value? Minus 1,000 and minus 4,000. This value will be x plus y minus 4000. This. So just now you can write constraints, all the constraints from here at the previous question, as like previous questions. What will be the value? Here, this is greater than equal to 0, this is greater than equal to 0. This means x is greater than equal to 0, y is greater than equal to 0, 7000 minus x minus y is greater than equal to 0. That is what? X greater than equal to 0, y greater than equal to 0, and x plus y is less than equal to 7000. This is first set. Similarly, second, this is greater than equal to 0, 4500 minus x is greater than equal to 0, and 3000 minus y is greater than equal to 0, and x plus y is minus 4000 is greater than equal to 0. So here, just what? So just x is less than equal to 45,000, y is less than equal to 1000, and x plus y is greater than equal to 4000. So these and these are the constraints. These are the constraints. And cost function. So cost function z equals to per liter per kilometer. So 7 kilometers and x liter and y liter. So 7 kilometer per liter 1 by 10 rupees. So 7 into 1 by 10 into x. 7 into 1 by 10 into x. So 7x by 10. 7x by 10. Similarly plus 6y by 10 plus what? 3. So 3 by 10 into this 7000 minus x minus y plus same here 3 4 2. So 3 by 10. So here 3 by 10 into in place of x this 4 5 minus x plus 4 by 10 into 3000 minus y plus 2 by 10 into this x plus y minus 4000. So you can get the value of z. Now for minimize this, just you can write LP. To minimize this, subject to constant this, and then you can draw the graph and can find the value of z, and minimum value is minimum cost at the point. Okay, so do complete this question in your copy. Also in the previous questions 6 and 7. Also do the questions from examples. These are long questions, but you have to do the formulation, and then just after formulation just draw the graph and find the reason and corner points. At the corner points, value of the function z, minimum value is minimum and maximum is maximum. As the case of reason is bounded reason. For unbounded, one other step is one. You know, I have already discussed in the previous section. So do all questions from this exercise and send me solution of at least 2 questions 6 and 7 for your attendance. Okay.